Cool Roofs channels, the Cool Roofs Indonesia. And representing the team here today is Dr. Bella Paramita, Assistant Professor in Architecture Study Program of Indonesia University of Education, UPI. Now, Bella, I'll hand it over to you.
Okay, thank you so much, Soyi. Can you hear me, everyone? So my name is Beta Paramita. So we have a team here. Also, I guess here also have Professor Raffi Srinivasan from University of Florida. I hope Jay also joined, but I cannot see him this night. I don't know, perhaps Jay also joined. So it's glad to share our work from 2019 until 2021. So yeah, compared with another team, I guess we have same struggle, we have same challenge that we face a lot of things, not just production, not just spreading the manufacturing, also spread the cool roof across the country. We also have a lot of barrier because most people have no good information about this product. So the first time when I ask people who going to join with our project, it's quite tough. But then I try to change the strategy between the U to U. I mean that between the university to university, I guess it's much more easier to approve. Besides, we not choose the residential building because in Indonesia residential building is quite small in density, not in density but in the size. But then I thought that the school in Indonesia more have the benefit if we took this project to the school. So we have more than here we have more than 11. Yeah, we have 11 school building, but so the total occupant who get this benefit more than 10,000 people. And then so we have a lot of measurement doing with the indoor and outdoor measurement. So when we took this measurement, we not just taken with the FLIR camera, we also put some surface temperature. So we got a lot of surprise actually, because this is very new for me as well. So when we took, this is the first pilot project from PT Mayora is one industrial building. We make the deployment around 5,000 square meter. So we quite surprised when we start the payment, the inside, the indoor temperature can, you can see here is 40 degrees Celsius. And then after the deployment, the cool roof installment here, they can reduce 11 degree. So here the canteen, the people sit here is have lunch. And they have the background, the back, they have very sweaty because this is a factory. And then when we make this installment, they can reduce 11 degrees. It's quite surprise for me as well. So this is also in Bandung. Tangerang is quite hot. The diurnal temperature maximum is 34 degree, but here is in Bandung, my city, myself. The maximum temperature is not so high. Only 28, but the design of the building, somehow in Indonesia we don't have any building code for passive design strategy. So somehow when people cut the not have some good strategy to design, you can see here that in Bandung, even on only 28 degree indoor temperature, previously 32 degree, and then after the payment, we know here that in the ceiling. So after payment, before it takes around 44 degrees Celsius, and then after the payment, we got 29, so around 30 degree. So it's quite surprising in Bandung itself when the low temperature also outdoor temperature is low, quite low enough. But somehow, if we don't have any passive design strategy, actually it will be makes more heat trap in the building. So this is another experiment of the cool wall. If you can see here that the material of the reflective paint can reduce, can have the same quality with the Hebel wall. Hebel wall is the lightweight brick. So we can see here that the interior temperature nearly same, only 0.1 different. This is normal, normal building, the right side, normal building with the Hebel with very thick wall. But this one, the metal house without any insulation, without any protection. So we just using the cool reflective paint. So the same interior temperature. Sorry. So the surface temperature also show the performer that the metal wall with the cool roof paint also show us that if we paint the wall with the cool paint, that will be nearly same with the Hebel. So Hebel is quite thick. So yeah, actually the conductivity is also quite good. But this metal is very thin, and they don't have the conductivity also very high. They don't have any insulation. So we can see here that the cool wall also successfully installed in Indonesia. Sorry. Okay, next. So this is the perception of the people from the residential building when we ask them how benefit or how they feel after the payment. They said actually 100%. They said this is very helpful and very helpful. And then one thing that we very happy about our project, that we help not just because they feel more comfortable, but they feel in Indonesia we have a lot of communal disease like TB, tuberculosis, also like asthma. So when we deploy this cool paint, some of them report us that they don't have any attack in the night. So like asthma, usually they have some asthma in the night, so they don't have any asthma in the night. So it's quite happy for us also about this result. And then when we talk about the motherhood here, so mostly people live inside is like mommy, like woman and their child. So they said that also this is very beneficial. So we can see here that most people are very happy with the result. So this is the policy engagement. As another team have struggle about this one, we try. This takes a lot of energy. Just one piece of paper we have to deal about with one government and another university and another government. It's quite takes a lot of energy and time. But then we still more effort to make some connection with the government, so they know exactly what we already done in Indonesia so far. And another thing that we want to do that people already notice about this project, it's quite important. From Aceh, from the west of Indonesia until east of Indonesia, Kupang, we've already deployed this cool roof. So when government asks me or ask our team, what is your proof, your something like your benefit, so we can have this official improvement. So what next when Indonesia stayed as a winner? For me myself, I took very long gratitude for all the collaborators here. So we tried to do the 3 years plan. That actually in the 2 years we just focus on the production. As I have also mentioned that production is quite challenging in some of the country. Same in my country, we don't have any raw material. We have to make the imported material. And then when the COVID hit our country, also there is a lot of forbidden activity. University closed, and then also shipment, all the island also difficult to access. Indonesia is archipelago country, so we have to access one island to another island by boat is quite difficult to access at that time. So we try to do this scale up in the next year, so we can face some commercialization. Not in last year, but in next year, we try to make some distribution and supply chains, because last year we just make something like CSR, not like commercialization. So after the commercialization, in the parallel, we try to make the laboratorium development, because in Indonesia, we don't have such kind like standard, national standard for SRI, solar radiation index. So we try to make some parallel with the corrosion, and then also addition test. And after we got the new product, also with J, we make some improvement, because it's quite different when J tried the first product in US, and then in Indonesia, perhaps we have different humidity. So we try to make some another development. So when we face some challenge with the climate, or also with the humidity, especially also with the pollution, Indonesia have a lot of pollution. So in the previous product, we just only 3 years long life. But then we try to make it more longer, the quality of the product. So with the lab development and also material improvement, we hope that our product have the more long life. And then after that, we want to make another scale up with the new product, because as I mentioned previously, that our product is more imported material. So we try to make the substitution with the local product. So our calculation prove that if we make some substitution with the local product, they're going to decrease 21% of the cost, production cost. So it means that the affordable people can access this product as well. So with our achievement now, I guess all the finalists here show us the lesson learned, show us how difficult new product to share to the people, share to the government, especially. I hope that we still have connection and we still have the network. So I hope next step we still have another collaboration. I guess that's all for me. Thank you and terima kasih.
Thank you so much, Bella, and really looking forward to the team's even greater success. Now that we've heard from all of our finalists, I want to invite Kurt and Ben back to the stage for a very, very quick reflection. So Kurt, I'm going to turn to you first. It's great to see the team have created a foundation for longer impact. But then now, how can the larger international community help? Could you maybe share some examples of opportunities here?
Sure, I'll be real quick. So first of all, in implementation, I think it really comes down to working in real partnership with flexibility to address the actual challenges that are often really hard to anticipate. I think we heard a lot about that today from these teams. But more broadly, I think Deborah in our panel made a great point, and that is that we need to consider cool roofs and passive cooling as a market, and it needs a package of diverse funding types. So we need the finance industry and development finance institutions to understand and properly value and de-risk these investments. It needs mezzanine and bridge financing to deal with the real challenges of standing up a new market. We heard some of that today: customs, tariffs, capital for local production that helps reduce costs and create local jobs and economic gains. And it really needs philanthropy to help low-income and vulnerable markets to access this new marketplace.